Welcome to Master Simple Physics. To learn physics, you must understand vectors and scalar. In part 2, it's Vector-Force and Scalar-Energy. I hope you do remember scalar and vector definition. Scalar is the emphasize of magnitudes, but without considering the directions. Whereas for vectors, there is a magnitude with directions. In last lesson, we have learned distance and displacement. In this lesson, we will focus on mass, weight, force, work, and energy. Weight is a type of force, and work is a type of energy. Some of you may not have learned force or different kinds of energy. Hence, in this slide, I will provide you the equations. Hopefully, you will be able to identify which one is scalar quantity and vector quantities. First of all, we need to identify the difference between mass and weight. Mass is the amount of substance of an object. Hence, mass is a scalar quantity because the amount of substance will not be changed whether they are on Earth or go to the moon or go to another planet. Whereas, weight of an object is the gravitational force acting on it. As we know, forces have different directions. Also, we look at the equation. Weight is also another form of force. Is equal to mass times gravity. G stands for gravity. F is equal to m times g. M is a scalar. G is a vector. Scalar times vectors will give you vectors. And F is a vector. Subsequently, we will explain what is called energy. Energy is the amount of work done. Energy is a scalar quantity. How do we know? Look at the expressions given below. Energy has different forms. They have work energy, gravitational potential energy, kinetic energy, heat energy, etc. How do we differentiate the expression that is a vectors or scalar? We have looked at the arrow on top of the letters. If you don't have arrow, that means it's scalar. When there is an arrow on top of a letter, it means it's a vectors. For example, 1, work is equal to E equal to F times S. F is a vector, S is a vector. Vector multiplied by vector will give you scalar. And E, work energy, E is scalar. 2, gravitational potential energy, short form we call GPE. E is equal to mg. G gravity is vectors, is hypervectors. Scalar vectors, multiplied vectors will give you scalar. 3, kinetic energy. Kinetic energy, K, short form is KE, is equal to half of mv squared. So V is vectors, and now V also vector, and vector multiplied vector will be scalar. The next one, heat energy, all of the letters m, c, theta are scalar quantity. Therefore, we conclude all kinds of energy are scalar quantities. Weight is equal to mg, which is equivalent to force. Now we look into this GPE, gravitational potential energy, is amount of stored energy in an object, which is proportional to its mass, its gravitational field strength, G, and its height. Now look at the left diagram. A girl is standing at the platform. We know that G is pointing downwards towards the earth. Hence, the force, or we call the weight of the girl, should be equal to m times g, which is also pointing downwards in the same direction of g. Look at the right diagrams. mg is the weight. So how about this girl is standing at a height of h above the platform? If we define the height above the ground, it is called positive, and the h H must be also in parallel or vertically parallel to G, then the gravitational potential energy is equal to mgh. Here we introduce another work energy equation. Sometimes we call work done. Work done is amount of applied force on an object to move it with a displacement. Hopefully by now you should know force and displacements are vectors quantity. And now we do more using the arrow because we want to save time. As we mentioned earlier, in order to multiply 2 or 3 parameters, we have to ensure that these few parameters are in parallel. Example, F is in horizontal, S must also in the horizontal position. If F is in vertical, then S also must be in the vertical direction. Let us try this example, see whether we can use the equation correctly. A 20-gram ball is released freely from the top of the slope as shown. Based on the given equations, to determine the energy used at different positions. Question 1 is to find the energy at position A. We give the equation that EP equal to mgh. Mass m is equal to 20 gram, which must be converted to kilogram, is equal to 0.02 kilograms. The height, as we know, is vertical to the G, hence is to be 1.2 meter from the ground to A. G is given as 10 joules per kilogram meters. Can you fill in the parameters with the values given to find the potential energy at A? The answer should be equal to 0.24 joules at the position at A. Question 2 is to find the work done at B, which is related to the downward force along the slope. The downward force is in parallel to the slope, which is the dissolved vectors for mg. The angle between the mg and downward force is 60 degrees. If we want to use 30 degrees, then our equation for F downward force is equal to mg sine theta. How about the displacement, which is the vectors? It must be in parallel to the downward force. So in these circumstances, the B position should be equal to 0.9 meter from A to B. Hence, S equal to 0.9 meter. Therefore, we use the work done equation E equal to mg sine theta times 0.9 equal to 0.09 joules. Question 3. What is the gravitational potential energy at B? In the previous calculation in 1 and 2, the potential energy at A is equal to 0.24 joules. The work done is 0.09 joules. The gravitational potential energy at A is the initial stored energy, and work done is the used energy. In order to determine the potential energy at B, we can have two methods. Method 1, we can reuse the equation E equal to mgh. In this equation, we need to find the height at B. Can you observe the small triangle in the main diagram, and I have projected it at the bottom of the slide. Since the ball has slid down 0.9 meters from the slope, so we have to determine how much it has traveled vertically. So from this diagram, we can see that it is equal to 0.9 sine 30 equal to 0.45 meters. Hence, the height from the ground to B, HB, is equal to 1.2 minus 0.45 meters. Therefore, you can find the potential energy at B is equal to 0.15 joules. Method 2, you will use additional methods. As we mentioned earlier, based on the calculation in 1 and 2, potential energy at A is the stored energy, and the work done is the used energy. Hence, we can use 0.24 minus 0.09 joules to to get a similar answer 0.15 as the method 1. Do you know why we can use additional methods? Because energies are scalar quantities. Now come to the end of the lesson. Shall we have a conclusion? For multiplication, B multiplied by C, if they are vectors, you will get scalar. For additional methods, if all are vectors, the rest must be vectors. So 1, if B is in y direction, C and D must be also in the y direction. 2, if B is 30-degree inclinations to the horizontal, then C and D must be parallel to B, as shown in the diagram. Lastly, hopefully you know how to use multiplication to get vectors and scalar. Thank you.